The history of calculus is an interesting story written by some of the greatest mathematicians of all time. But first, let's go back to the basic. The standard definition of calculus. So, calculus is the mathematical concept that discusses how something changes continuously. There are two underlying branches of calculus: the tangent problem, which uses differentials, and the area problem, which uses integrals. Let's say there is a velocity time function f, t. The slope of f, t, at t equals t0 tells us the instantaneous rate of change of velocity, or the acceleration. This is the differential method. While the integral calculus results in the sum of distance traveled between times a and b by computing the area enclosed by f, t, in the interval a and b. Today, people accept that calculus involves two big contributors: Sir Isaac Newton, a scientific titan, aka the Apple guy, and Gottfried Wilhelm von Leibniz, another Isaac Newton opponent. But, was calculus actually founded by that time? Of course not. However, we have to acknowledge that the two fathers combined past achievements from other great mathematicians. Going back in time, we find that Greek mathematicians have been interested in the area problem since 400 BC. So, let's us go back to this time. You know there were a lot of pyramids in ancient Egypt, right? And the Egyptians wanted to estimate these construction. Well, this math had been already solved in the manuscript of Rhind papyrus since 1600 BC. The formula of pyramid's volume with a rectangular base was 1/3 the area of the base, multiplied by the height. But they couldn't find the evidence on how did they found it. Moving forward to 3rd century BC, we have Euxodus of Cnidus as our contributor of this time, as he proved the mathematical formula of pyramids and cones volume with the method of exhaustion. Later on, around 225 BC, Archimedes took this method to further steps to prove that the area of a circle is equal to pi r squared. He started with the parabola and a triangle of area A. By applying the method of exhaustion, Archimedes designed an infinite series of triangles until the parabola is reached. Result in the area of the segment of the parabola is 4/3a. Archimedes also used this method to estimate the area of a circle. He did this by increasing more sides of the polygon inside the circle until it has practically become the circle itself. This is an early illustration of integration. Archimedes made one of the most significant Greek contributions around 225 BC. Around 320 AD, Pappus, a Greek mathematician, he estimated the volume of a rotating cube when a planar figure was rotated around a non-intersecting line. But he didn't explain it. For the next 1,300 years, no remarkable discoveries were made until an explosion of achievements in the early 17th century, aka Precalculus period. In 1630, an Italian mathematician named Bonaventura Cavalieri found how to calculate area of a plane figure, contributing to further development of integral method. But his solution was too hard to understand, so, rejection. 5 years later, French jurist and mathematician Pierre de Fermat proposed solutions for maximum and minimum, the tangent problem of y equals x to the power of n, suggesting solution for integrals problem. But he didn't use the limit approach, so just close, but not accurate. Then we have Isaac Barrow, Newton's teacher at the University of Cambridge, who almost complete the fundamental theorem of calculus. Even so, his achievement had so much influence on both Newton and Leibniz later on. The Newton and Leibniz era. They were credited as the inventor of calculus by their work of refined and standardized the past achievement. However, it occurred that there was an intense battle of plagiarism between the two mathematicians. Leibniz, I published my work to the public first. And I did it twice, in 1684 and 1686. So the invention of calculus belongs to me, Leibniz. Newton, but I did research about it long ago, back in 1666, but just didn't publish it. My acquaintances and my dear friends, all of them witnessed my process. But what Leibniz put out was just a single result. Newton's complete work in the 18th century was more systematic and well written. Another problem arose as Newton's version looked a lot like the flawless work Leibniz had done before. People started questioning as plagiarism of Leibniz's ideas. Similarly, numerous suspicions that Leibniz plagiarized Newton's ideas through the correspondence Newton shared with colleagues. But there is one thing that we need to aware. The Leibniz's system can be more optimal than the Newton system. Why? Newton's theory was based on the relationships between real physical quantities. So, his approach is extremely geometrical and not applicable. While Leibniz used algebraic approach, relating dy over dx, which can be used to solve non-y equals f, x, curves. Despite those controversies left behind Leibniz and Newton, we must admit their contribution of a fundamental mathematic foundation. Thank you, and I'll see you soon.